to, can somebody read off the numbers?
Add 1 minus 1/3 plus 1/5 minus 1/7 plus 1/9 plus ellipsis plus 1/9.
Okay, well, except for the first number, it looks like we've got 3, 5, 7, 9, all of the odd numbers. Can I make 1 look like 1 over an odd number?
1 over 1.
Yes. So let's play with this. We want to write sigma notation that represents this sum. Let's play with it in 2 separate strains. Let's ignore the signs and just look at the terms. So I've got a 1 here. I could have I equals 1, I equals 3, I equals 5. Oh, but we don't have that kind of ability to skip integers. So, gosh. There are 2 different ways. Well, first of all, the easiest way to break integers into evens and odds. 2n, let's make it 2i. 2i are all even numbers. And 2i plus 1 are all odd numbers. And let's see what this form 2i plus 1 allows us to do. If I is 1, and actually we're going to start with I equals 0. So if I is 0, what is 2i plus 1? 2 times 0 plus 1 equals
1.
1. And then we move to 1. 2 times 1 plus 1. Well, that's nice. I equals 2, because this is how sigma notation works. We have to hit every integer from wherever we start to the end. And by separating the integers into 2i and 2i plus 1, I can describe in one in one pile, all of the odd numbers. So I could, it looks like if I had 1 over 1 plus 1 over 3 plus 1 over 5 plus plus 1 over 19, I could write this. Where did we say that we need to start? What number?
0. 0.
At 0. And let's solve, if I have 19 is equal to 2n plus 1, what is n? How can I find out?
9.
Yeah, we're subtracting 1, we get the 18 is 2n, or the n is 9, and that means we go up to 9, and we have 1 over 2i plus 1. Is that right? So if we only have plus signs, between the terms, then 1 over 2i plus 1, where I runs from 0 to 9, will describe every one of these. If no, Lauren says no.
Because there's negatives.
Oh, right, so this is if we only have
Oh,
pluses.
sorry.
So if we only have pluses, this will work. But we don't only have pluses. And some of the odd numbers are subtracted and some are added. It looks like every other one is subtracted. So we need to take our 2i plus 1 and break it into two parts. And we're gonna do that using 4i plus 1 and 4i plus 3. So, I don't know. Let's look, let's see what happens. I have 4i plus 1, 4i plus 3, and we're starting with I equals 0. What is 4i plus 1 if we're starting with 0? Okay, and what is 4 times 0 plus 3? Okay, that's interesting. So we have 4 times 0 plus 1 is 1. 4 times 0 plus 3 is 3. So it works, this way of dividing all of the odd numbers into 4i plus 1 and 4i plus 3 works for the first two. Let's see what happens when we go up to I equals 1. So we'll have 4 times 1 plus 1 and 4 times 1 plus 3. 4 times 1 plus 1. 4 times 1 plus 3.
And 12.
Beautiful.
Oh, 7.
Let's see, I'm gonna skip I equals 2. I wanna go to the last one. I'm not sure how many to do. So let's just see what happens if we look at I equals 4. We'll have 4 times 4 plus 1, which is 4 times 4 plus 1. Beautiful. And we'll have 4 times 4 plus 3. And now I can see how to write this original. Because the first two are I equals 0. The second two are I equals 1. The next two are I equals 2. And the last two are I equals 4. So we've got the sum from I equals 0 to 4 of 1 over 4i plus 1 minus 1 over 4i plus 3. Does that work? When I is 0, which two terms do we get?
1 and 1,
Yeah. 1 and negative 1/3. When I is 1, oh cool. When I is 2, what is the matching term here?
Negative 1, 11.
Good. I'm gonna go ahead and write in the missing terms. For I equals 3, what are our terms?
113.
And for I equals 4.
117. Negative
we're looking for patterns, and some of this is, I'm throwing it at you so that you can learn the kinds of ways to break up numbers. All of the odd numbers are two odd plus ones, all even numbers are two odds, and we can break up the two odd plus ones into two piles, 4i plus 1 and 4i plus 3, which is a very handy thing. And now, any questions about this guy? Now, what if we had 1 minus oh yes. 1 minus 1/2 plus 1/3 minus 1/4 plus dot 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 plus 1/10. This will be a minus. Oh no, this will be, yeah, no, that's right, 1/10. This time, it looks like I've got 1/i for I goes from 1 to 10. But there's an extra part up here. What is the extra part?
The signs are changing.
The signs are changing. So let's see, I've got the sum as I goes from, what's our smallest value?
1,
Good, and we're going up to,
10.
good. And we know we've got this 1/i. But now we need something that we call a switch. So we need, and I'm gonna move this over so that I can have the switch in front. I've got 1/i. And I've got a switch that I want to go back and forth, positive, negative, positive, negative, positive, negative. And I need to do that using I. Well, what about -1 raised to the 1? What is the sign? Negative. And what about -1 raised to the second?
Positive.
And -1 raised to the third? And what is the pattern?
Negative plus
Yeah. -1 raised to the I. But I wanted to start positive. Does this start positive?
No,
So how can I fix it?
maybe by saying I is equal to 2. But
Then I
you're
won't
gonna
have
mess up.
this. So,
By adding another one,
so can we? Can we change that to I plus 1?
sure.
Now, at 1, when I is 1, what is the power?
2.
2, and -1 to the second is
2.
positive.
Okay.
And then when I is 2,
We have 3.
we'll have 3, which will be
Negative.
negative, and so we get that pattern. I want you to look for these patterns. And I do kind of apologize, I made it so that try this 2 is super easy, but try this 2 starts out with -1 plus 1/2 minus 1/3 plus minus dot dot dot, and we go up to okay. So play with that.